Hello everyone, welcome to my YouTube channel. In this video, I am going to discuss two important theorems on Z transform, which are known as initial value theorem and final value theorem. So first we take initial value theorem, which states that if Z transform of a sequence un is u bar z for n greater than equal to 0, then z tending to infinite of u bar z gives u0, that is the initial value of the sequence un. So this is the initial value theorem, that if z transform of un is u bar z, then z tending to infinite limit of u bar z gives the initial value of the sequence, that is u0. Now we prove this result. So given z transform of un is u bar z, and by definition we know that it is summation n goes from 0 to infinite un into z power minus n for n greater than equal to 0. Now u bar z is equal to, we expand this summation by putting n equal to 0, 1, 2, 3 and so on. We get u bar z equal to, for n equal to 0 we get u0 into z power 0, that is u0, plus for n equal to 1 we get u1 into z power minus 1, that is u1 by z, plus for n equal to 2 we get u2 into z power minus 2, that is u2 by z square, and plus so on. Now we take limit z tending to infinite, then we get z tends to infinite u bar z is equal to z tending to infinite of u0 plus u1 by z plus u2 by z square plus u3 by z cube and so on. Now for z tending to infinite, u1 by infinite, u2 by infinite, all these terms are 0 in case of limit, and we have only u0 in right hand side. So we get z tending to infinite u bar z gives u0, the initial value of the sequence, and this is the initial value theorem. Further, using the initial value theorem, we can find next initial value u1, u2, u3 and so on. So as a part of deduction of initial value theorem, we can deduce from equation second, we can write u bar z minus u0 is equal to u1 by z plus u2 by z square plus so on, and then we multiply it by z, that is z multiplied by u bar z minus u0, then we have z into u bar z minus u0 is equal to u1 plus u2 by z plus u3 by z square plus so on. Now we take limit z tending to infinite, then in right hand side u2 by infinite plus u3 by infinite and so on are 0, and we have only u1 in right hand side. Then we get z tending to infinite, z into u bar z minus u0 gives u1, that is the next initial value. And similarly we can write from equation 2 that z square multiplied by u bar z minus u0 minus u1 by z, then in right hand side we have u2 plus u3 by z plus u4 by z square plus so on. So from equation second we transfer u0 and u1 by z in left hand side, and then we multiply whole equation by z square, then we get this expression. Now we take limit z tending to infinite, then these all terms are 0 in the right hand side, and we have only u2 in right hand side, and therefore we get z tends to infinite z square multiplied by u bar z minus u0 minus u1 into z inverse gives u2, next initial value. So similarly we can find next initial value u3, u4 and so on using the initial value theorem. So these are few deductions from the initial value theorem. Now we take next theorem, which is called final value theorem. Final value theorem states that if z transform of a sequence un is u bar z for n greater than equal to 0, then z minus 1 into u bar z, z tending to 1 gives u infinite. That is un n tends to infinite, the final value. So this is the final value theorem. Again, final value theorem is what? If z transform of the sequence un is u bar z for n greater than equal to 0, then z tending to 1 of z minus 1 into u bar z gives u infinite or n tending to infinite un. Now we prove this result. So given z transform of un is u bar z, and which is by definition is summation n goes from 0 to infinite un into z power minus n. Now we find z transform of the sequence un plus 1 minus un. So by definition z transform of un plus 1 minus un is given by summation n goes from 0 to infinite un plus 1 minus un multiplied by z power minus n. Now in left hand side we apply linear property of z transform. Then we have z transform of un plus 1 minus z transform of un is equal to summation n goes from 0 to infinite un plus 1 minus un multiplied by z power minus n. Now by using shifting to left property, here for z transform of un plus 1 we use shifting to left property, and by which we get z transform of un plus 1 is z into u bar z minus u0. We already discussed this deduction in shifting to left property in previous video, where we get z transform of un plus 1 for k equal to 1 is z into u bar z minus u0 minus here z transform of un is given u bar z is equal to summation n goes from 0 to infinite un plus 1 minus un multiplied by z power minus n. Now here we take u bar z common, then we get z minus 1, and here we have u minus u0 into z, which we transfer in the right hand side. Then we get u bar z common, then we have z minus 1 into u bar z minus u0 into z we transfer in right hand side, then we have u0 into z plus here limit of summation is from 0 to infinite. So we express this limit as 0 to k, and k tends to infinite. So we have 0 to infinite un plus 1 minus un multiplied by z power minus n. So here n equal to 0 to k and k tends to infinite gives n is 0 to infinite. Now we take z tending to 1 limit in both sides, we get z tending to 1 of z minus 1 into u bar z is equal to z tending to 1 of u0 z plus here z tending to 1 of k tends to infinite summation n goes from 0 to k un plus 1 minus un multiplied by z power minus n. Now we have z tending to 1 of z minus 1 into u bar z in left hand side as it is, equal to, here z tending to 1 gives u0 plus k tends to infinite summation n goes from 0 to k un plus 1 minus un, and z tending to 1 gives 1 here. Now putting n equal to 0, 1, 2, 3 up to k, and we expand this summation, we get u0 as it is. For n equal to 0 we get u1 minus u0 plus for n equal to 1 we get u2 minus u1 plus for n equal to 2 we get u3 minus u2 and so on. Finally for n equal to k we get uk plus 1 minus uk. So here k tends to infinite. Here positive u0 negative u0 cancel, positive u1 negative u1 cancel, positive u2 negative u2 cancel, and up to positive uk and negative uk cancel, and we have only uk plus 1 as k tends to infinite. So we get z tends to 1 of z minus 1 u bar z is equal to k tends to infinite uk plus 1, and k tends to infinite uk plus 1 gives u infinite. So this is the final value theorem, that if z transform of a sequence un is u bar z, then z tending to 1 of z minus 1 into u bar z gives the u infinite. So these are two important theorem, initial value theorem and final value theorem. In next video we will discuss university examples on Z transform. So see you in next video. Thank you.